Today I am going to discuss about some basic of tree in data structure. So now it starts. Tree. Firstly, we know that types of data structure. We already know about data structure. There are two types, just simple data structure and complex data structure. So in we can say, and we see in simple data structure is integer, float, char, pointer. And in complex data structure there are two types. Firstly, linear data structure and then non-linear. So we see in linear array, stacks, queue, list, and in non-linear we see tree, graphs, and files. So we can see right now tree. So before that we see array, stacks, and queue. So now going to start tree. So firstly, when the tree word comes in mind, tree, then we think about the just like mango tree, just like this. So if you think any tree, then you imagine that one root, this type. So this type, this is the root, this is sub branch or sub branch, and this is leaf. So this is the in our day-to-day life, just like you see the any tree, just when we think about the tree. But in computer language or in data structure, and this is the reverse of this, just like when we in the tree, root is below, but in data structure root is upper portion. So that's why in data structure this structure are in form of tree. E, F, G, H. This is right. Okay, right or left, you can anything, take anything. So that's why, so I, J, K, and for G, to tree, to child, child, L and M. So here this is the leaf, I, J, K, L, M in the leaf node, and this is the root node. So you can see the difference between original tree and the data structure tree. So now we can see about other things. So now I'm going to see some basic terms related to tree. So firstly I say root, firstly I see node, then root, then edge, parent. So root, node, edge, parent, child, sibling, leaf, internal node, degree, level, height, depth, path, subtree, and lastly ancestor and descendant. So one by one we can discuss. So in node, firstly we say before root we can see the node. So what is node? So in just you see this tree, element of the tree is known as node. Just A, B, C, D, E, F, dot, E, F, I, J, E, F, G, H, I, J, K, L, M. This is the node. And after that, root node. What is the root node? So starting node of a tree. Okay, a starting node. Just A is the starting node. So this is the root node. And here A is the root node, and B in a tree only one root node. So I'm going to see edge. So link or connection between two nodes. Just like what is the edge? Just we can see from between A and B. This is the connection. So the connection between two nodes definition is connection, link, or connection between two nodes of a tree of a node. Connection between two nodes is edge. So this is node, this is node. So we can find the node also, because in a tree having nodes, then n number of nodes. If tree is having n numbers of nodes, n number, then n minus 1 is edge. That's like n minus n number of nodes, and n minus 1 is edge. We can see here how many nodes: 1 2 3 4 5 6 7 8 9 10 11 12 13 nodes. So here is 13 minus 1 edge, it means 12 edge. Now we can say edge. So again after that we see parent. So here we see that node having child or branch. So it means node with branch from top to bottom. Just we see in the tree here we see A, B, C, D, E, and G are the parent nodes. So here we see clearly we see. So A have a B, C, D child, and B have E and F child, C have G child, H D child. So H is the H is child of D, so D the parent of H. A is child of B, C, D, so A is the parent of B, C, D. So that's so A, B, C, D, E, G are the parent nodes. Again we see child node. So those nodes with edge from bottom to top, or branches of parent. So any the node with edge from bottom to top, just like a branch of parent. Just B, C, D. This is the parent node. So or A also the parent node of B, C, D. So the branch of all the branch of a parent node, just like B, C, D the branch of A, E, F branch of B, G branch of C, and H branch of D, and again I, J, K, L branch of E, and L, M is branch of G. So 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 that's why so that's why this is that's why B, C, D, E, F, G, H, I, J, K, L, M are all are child node. Okay, then again B, C sibling. Okay na. So sibling B, C here child node of same parent node. Okay, so child node have same parent. Here we clearly sentence that we in this sentence clearly show that child node of same parent. It means B, C, D. This is the child node of same parent A. So here also B, C, D, E, F. Here E, F same parent B, I, J, K same parent E, L, M same parent G. So for in this tree B, C, D, E, F, I, J, K, L, M are siblings. Okay, then B, C leaf. So those node having no child node. Okay, just like leaf node is the last node of a tree. So how they have any child? So I, J, K, L, M are the leaf node. Leaf node because they have no any child node. After this the tree are after this there is no child, so that's why H also is leaf node. Okay na. So okay, fine. And after this non-leaf node, it is also called internal node. So except this leaf node all are the internal node or non-leaf node, just like except I, J, K, L, M and I, J, K, L, M, H, sorry, and not H. So except this leaf node, all are A, B, C, D, E, F, G are non-leaf node or internal node. Okay. Again I say child, sibling, leaf and internal. Again and then after I see the we see the degree, level and height, depth. So we can say degree. So here degree of node, degree. The degree of node is number of child node. Simply degree of node, it means number of child node. So that here degree of A and B, C here in this degree of here B, C degree of A number of child B, C, D. Okay, so there is 3 number of children or there are 3 number of child of A. So degree of A is 3 and degree of B, it means here E and F are the child of B. So B have 2 children, so or 2 nodes or 2 children nodes, so that's why degree of B is 2. Degree of E here, so degree of E have I, J, K, it means in the children node of E is 3, so that's why degree of E is 3. So here we can see one important note, that's maximum degree among all nodes equal to degree of tree. It means when we see all degree of all nodes, then from among all the degree from all among node, the maximum degree are known as the degree of tree. Okay, so here degree of tree is 3. After that level, we can see level. What is level? every step or hierarchy in tree level, just like we see here, we see in this example. Okay, so here this is one level, this is two level, no, sorry, level starts from 0, then again. So here we see one important notes, level starts from 0, and for every step hierarchy level will be increasing by 1. It means when we take 0, then it increase by 1. The 0 plus 1 is equal to 1, again 1 plus 1 is equal to 2. So by increasing 1, the level of degree increasing. So here we see the degree of age 0, degree of here level, not degree. So level of here 0, again 1, 2, 3. So here we see maximum number of degree 3. So after the branch of A, firstly root node level is 1, level of B, C, D is 1, level of E, F, G, H 2, and level of I, J, K, L, M 3. So here is maximum level of this tree is 3. So that's why we can also say that level of this tree also 3, because the maximum level. So and we here also in important note, level of root. It means what is the level of root? 0, nothing else. Okay, then we see height. What is the height of tree? So here is height. Longest path from leaf node to that node is height. Longest path from the leaf node. Okay, so here we see longest path. Where is the longest path? So we see if we take B, so what is the longest so what is the longest path from that node to root node? So B to A. So here is height means longest path from the leaf node to that node. It means from BC, from here, last one, from that from last to given node. So if we take B, then what is the longest chain? What is the longest path? So I from BC, from I, then E, then B. So we also see J and K all are same children of same parent, child of same parent, I, J, K. So we take anyone. So here longest is I, E. So only 2 node in this chain. So height of P is 2. Again when we take A, then what is the longest chain? We see here 1, 2, there is 2. Oh, hello. So there is 2 node. So there is 2 node, and when we see here C, again J, L. So from L 1, 2, 3. When we check here also, I, E, B, A, 1, 2, 3. Here also 3. So the maximum number, the maximum number of node in longest path is 3. So that's why height of A is 3. So here we take a note that height of tree is 3. Longest path from the leaf to root node. It means we find any node for the height of any node, but if the be the longest path from the leaf node to root node is known as the height of tree. So again we see after the height and after the degree we see leaf height, again we see depth. Now we see depth. What is the depth? So longest path from the root node to that node. It means first time we see I some mistaken. So in depth case, the longest path from the root node to that node. It means depth we find take the E. Then what is the depth of E? So from root node to that node, it means we take from top of the tree. So it means A, B, only two node find from root node to that node. So that's why and depth of E is 2, and we take depth of I. It means we take I. So what is the longest path from to that to root node to that node? It means 1, 2, 3. Here 3. H, when we take H, it means D and A. It means longest path 2, and this longest path from root node to that node, it means D and A. So here is a depth of is 2. Again we see path. What is the path? So sequence of consecutive edge from source node to destination node. Okay, so what is the sequence of consecutive edge from source node to destination node? So we can take any node to any node, just like we take A to K. Okay, so A to K, it means what is the source node? A, again B, again E, then K. It means, and this is the A, B, E, K. This is the path of A to K. Again, and after that we see the subtree. What is subtree? Here is we see also depth, path, and right now we see subtree. What is subtree? So the node with children form subtree. Simply we take another example here. It means we take A, B, C, D, E, F, G, H, I, J. Here B is another subtree, one subtree, and this is another subtree. Again this G, I, J is another subtree. It means simply those node have child node, it is another subtree. This is separate subtree. Okay, this subtree, this subtree, this subtree. Okay, and these whole are the parents subtree, and the whole are the one tree. So again one last topic, ancestor and descendant. So we see very few books or any very few places this ancestor and descendant are given. So we see the ancestor. And so what is ancestor? Any predecessor node on the path from root to that node. Okay, so ancestor of L. Here we see any predecessor. It means I take the example then quickly. So when we take L, okay, here L. So what is the predecessor? Predecessor means upper part from that node, upper chain from that node. So what is the upper chain? A, C, G. It means A, C, G are the ancestor of L. Okay, if we take F, what is the ancestor of F? B and A. B and A is ancestor of F. Okay, again BC is the BC descendant. So here is the definition: any successor node on the path from that node to leaf node. So here any successor node on path from that node to leaf node. So when we see we take C, then again we take this example from we take C. What is the descendant of C? So by the definition, we see successor node on the path from that node to leaf. So what from the successor from downward. So from C, what are the downward node from this place? What is the nodes below this? So G, L, M. So here G, L, M are the descendants of C. When we take B, so we see here what is the node below B? E, F, I, J, K. These all are 5 node are descendant of B. Okay, again at last we see some important notes regarding this. We see here from ancestor and descendant, we conclude that common ancestor of 2 or more nodes are possible, but common descendant are not possible. Here we see here B, C, D. Okay, common ancestor. Okay na. So when here we take a G and H. So here we take a C, G and H. So G, what is, where is the G and H? What is the common ancestor? What is the common ancestor? C is not common ancestor, D is not common ancestor. A is the common ancestor because the ancestor of G is C and A also, and ancestor of H is A and D. So A is the common ancestor of G and H. Likewise, common ancestor of E, G, H. E, G, H. What is the common ancestor of E, G, H? A also. Here also is A common ancestor. When we take E, F, then the common ancestor is B and A also. So here B and A also. If you take any another example also, if we take I, J, K, here is the common ancestor E, B and A also. Okay. When we take B, C, D, what is the common ancestor? A. Okay na. So that's here in this conclusion. But if we take we find a common descendant, then we take any example, there is no common descendant, because when we take C and D, okay, so what is the common? There from downward there is no common any nodes, so that's why no common descendant. So this is the some basic okay, some basic terms regarding the tree. Now we see here are some mistake by me. I am not paying attention here that time regarding leaf and non-leaf. Here we not include F that time, so here F is already included in leaf, because after the F there is no branch or no nodes or no child, so that's why F is also a leaf node. So nothing else, I am not paying attention that time, so that's why here is true also, because A, B, C, D, E and G are non-leaf or internal node. At that time I speak wrongly E and F also, we include F also that time. So that's it, nothing else. So this is the basic terms regarding tree, which are very important and very useful for the further study regarding tree. So okay, that's it. Thank you.